Okay, you guys, so the first thing I want to talk about with chemical bonds, I'm not going to actually start at the beginning. What I'd like to do is move to the end. So if you scroll down to the end of the notes, it looks like I'm going towards slide number 12. So if you can find this slide, please, on dot diagrams, this is what I'd like to start the discussion with on these notes, and then we'll go backwards and work our way forwards. So if we go to the dot diagrams, so the first piece I want to talk about, you guys, with electrons and being stable, what we need to start looking at first off is this stable or idea of being happy right here. All atoms are looking for 8 electrons in their outer energy level to become stable, and we'll talk more about that in a bit. Some elements are only looking for 2, but like I said, we'll get to that. The idea I want to get across is right here, this idea of valence, the valence energy level. Valence simply means the outermost energy level. That's all it means. I compare that to clothing. When you and I are wearing clothes, we can only see the outermost garments. Now that we're coming up on winter time, we might have a t-shirt on, then a sweatshirt, then we might put a coat on. So we've got multiple layers. We can't see those inner layers. We can only see that outermost. Now, of course, if you take your coat off, well, then maybe now we can see your sweatshirt. Well, now your sweatshirt is the outermost. And then if you get hot and you take your sweatshirt off, well, then you have your t-shirt on. Well, now your t-shirt is the outermost. And so we've got these different layers, and as we take layers off, something new becomes that outermost layer. So where we're at with our chemistry studies is the focus on the valence energy level, or that outermost energy level. And so our diagrams are going to become a little more simple than what they were, in that we're just going to look at those electrons. So if you look at the table that is on this slide, what we have, if I look at hydrogen right here, well, we see the element H and it has 1 dot. Well, hydrogen only has 1 valence electron. And then I look at beryllium. Beryllium has 2 dots. Well, beryllium has 2 valence electrons. And as we move across the table, we see that the number of valence electrons increases by 1 each time. And so down here, group 1 has 1 valence electron. Group 2 has 2. Group 3 has 3, 4, 5, 6, 7, and 8. Right here, and we skip, they're called transition metals, you guys. We skip those. They also have valence electrons, but they just don't follow the nice, neat patterns. So they have them just like everything else, but they just don't follow nice, neat patterns like groups 1 through 8. So what we're going to practice, you guys, is doing some dot diagrams. And dot diagrams show the valence electrons only. And so by drawing them, it's really easy to see if atoms are going to gain or lose electrons, and so we'll see those. So in a moment, we'll do those items across the bottom, but what I want to look at first is here. I've got a drawing for aluminum with a mass of 27. And we've seen these drawings before. And so here's the information that we would have done already. We've got that atomic number of 13, mass number 14, and then you can see the protons, neutrons, and electrons. So we've seen this before, and then you can see the drawing that I've got. But we're kind of done doing these drawings. We've moved past that. And so the nucleus, right here, again, we've done this, and we just completed our unit on nuclear chemistry, and we're kind of done with the nucleus. It's an important part, but you and I, we don't need to draw it anymore, so I'm going to get rid of it. That's leaving our drawings. Excuse me. And then if we take a look at aluminum, aluminum has 1, 2, 3 energy levels. Excuse me, mentioned that before. In terms of layering of clothing, we've got 3. This is the outermost energy level, or the valence energy level. That's the one that we're interested in. We're not interested in the inner energy levels, so I can get rid of those as well. So I'm going to get rid of this inner energy level. Not concerned with it. Excuse me again. And I'll get rid of the second energy level because I'm not concerned with it. So all of the things that I got rid of in our current drawings, we're going to substitute that, and we're just going to do the formula. So that formula, or symbol, I'm sorry, symbol for aluminum, capital A, lowercase l. That's now the nucleus and all the inner energy levels. And if I look at that outer energy level, aluminum has 1, 2, 3 electrons. And now what we'll do with our dot diagrams, we're simply going to add that number of dots around the symbol. So for aluminum, I'll add 1, 2, 3 dots, similar to what we did with those electrons. That represents the outer energy level, and I'll get rid of all of that stuff. And so there is our dot diagram for aluminum. It's the symbol with however many dots representing the number of electrons in the outermost energy level. So if I go back here, I've got some examples down on the bottom. If I look at carbon, carbon has 4 valence electrons. 1, 2, 3, 4. Calcium has 2, 1, 2. Potassium has 1, 1. And now you go ahead and give bromine and neon a try. Our last slide simply shows you guys bonding patterns, and we'll get to this eventually as well. Sodium has 1 valence electron. Chlorine has 7, and so bonding patterns, sodium will give up its electron to chlorine, and so now they both have full outer energy levels, and now they are both considered stable. And then that forms a chemical bond, and so those two are now bonded together, and we would call that sodium chloride.